Right, the number e. Now, I'm not going to go into too much detail of the number e. If you want to research it, go ahead. Leonhard Euler named this number e, okay? But it's based on this here. Okay, remember, look at the compound interest formula, okay? But it's based on this part here. Now, if I put numbers into here, so n, if I put, 1 into there, what do I get? Apparently, I get all these numbers down here, okay? If I put 4 into here, but the more and more you go on, the closer to e this actually becomes. I can actually show you what e is. It's this number here. So 2.7182, it's a bit like pi in so much it just goes on forever. Okay, so e and pi are one of those kind of magical numbers. Okay, so if I go back to this, let's try this in the calculator. Okay, 1 over, let's try a million. Okay, right, 1 divided by 1 million. 1, 2, 3, 1, 2, 3 is that. Add a 1. Raise it to the power of a million. 1, 2, 3, 1, 2, 3. 2.7182804. 2.7182818. Okay, I need to go further. Okay, instead of a million, let's try a billion. Okay, cancel that. Right, 1 over a billion. 1, 2, 3, 1, 2, 3, 1, 2, 3. Add a 1. Raise that to the power of a billion. 1, 2, 3, 1, 2, 3, 1, 2, 3. 2.718281827. 2.7182818. Okay, so again, you have to go on and on for kind of ever with n, bigger and bigger, to get it closer to e, which is why we'll never get an exact answer. Okay, it just goes on forever. Okay, that's e. Now think about it. E is just something in between 2 and 3. All right, that's all you need to think about right now. Okay, so how do we graph e to the x? Well, remember 2 to the x, so we don't have it up now. But look, here we go. Looks very similar. Okay. There's an exponential graph, again crossing through 0, 1, okay? Here's the reflection over the y-axis, so that's e to the negative x. Now you can think of this as 2 to the x won't quite be as steep as e to the x, when you look at this area here. And e to the x won't quite be as steep as 3 to the x, because e is somewhere in between 2 and 3, okay? But they all look kind of similar. Right, transformations. E to the x plus 3, this is the e to the x graph. The exponential graph moved 3 to the left. Here it is. So again, instead of crossing through this point here, okay, 1, 2, there it is, that point moves to there. It's hard to see with the, again, horizontal movement, okay, but there you go. I've moved it 3 to the left, okay. Right, this one. Now this is going to be reflection through the y-axis, isn't it? Yeah. And also horizontally stretched. Again, you'd have to go back to transformations to look at this. But the main thing is it's been reflected to the y-axis. Okay, so here it is. Remember, originally it was like that. To the y-axis and horizontally stretched. If you look at this again, so not quite as steep as this one. Okay, horizontally stretched. Finally, what's happened here? We have a y-axis reflection. It's going to be a little bit steeper. We've got x-axis reflection. And it's going to be moved up 1. Okay, a lot to think about. Right, so I'll look at it here. What should we do first? I don't know. Right. Okay, so maybe reflect it through the y-axis. So if I had this, if I do it in stages, do it yourself. So remember, here's the original. Reflected through the y-axis, if I do that one, it'll look like this. Reflected through the x-axis, it'll look like this. And then moved up 1, it'll look like this. Okay, so there you go.